standard weather balloon. It's about 6 foot in diameter. Every day can be a weather challenge. You know, we've got fog coming in off the Gulf. You get the sea breeze front, which is just a coastal type thing. There's all kinds of different things that happen here.
Everything that we do involves the weather, whether we're planning outdoor activities, whether we got things going on indoors. The weather can impact, people on travel, going to locations, and so the weather kind of is a focus for society in general to be prepared for what they're going to be doing during the day or night.
The weather is always changing, and even if the storms are coming, there will be different type of elements to them. Like Hurricane Rita was different than Hurricane Ike. Even though they were both hurricanes, they were totally different in the way they hit our area and what they did.
You never know what to expect. I've never been to any scene or any disaster that's, it's just the same as the last one. There's no such thing. You can go from a hazmat incident where it's spilled out on the road. You can go to one where it's leaking into a creek. You could go to a hurricane, a tornado that just knocked over some trailers, a flood in Orange County. Literally, there's no such thing as cookie cutter incidents.
If we're saving people's lives, and we do, I think, do that at times, that's really rewarding to know you're doing that.
Always a lot of coordination going when you're doing a drainage project that's covering a lot of ground. We're always digging ditches or laying culverts that are going to intercept or interfere or conflict with the city street, the city water line, a city sewer line. So we're working a great deal with the city of Beaumont. They have water department, sewer department, street department.
The future looks very bright because they stood up a national water center, which the whole thing is to try to develop models that you can see inundation happening in real time and forecast into the future. And so that would revolutionize the way we do flood forecasting. Now with more computing power coming on board, we're actually able to physically model the hydrology at just about every location in the United States, which you asked me that 5 years ago, I'd have said that would have never happened.
I'm the observing program leader here.
My official title is Service Hydrologist.
I'm a certified floodplain manager.
What you would consider kind of the outreach coordinator.
We do lots and lots of coordination to get the required resources into the county. We are the direct go-between with the county and the state.
I developed the forecast or the stages that trip critical thresholds for when we issue flood warnings.
I'm either going on the road or setting things up to go on the road to go out in the community and talk to people about the weather.
My job is to develop those thresholds and so that people along the rivers can actually begin to take action if they need to.
Maybe something like going to the schools and talking to kids about the weather. It may be going to a retirement home and talking to the people that live in a retirement home. I may be going to a hospital, talking to hospital administrators. I could be going to elected officials, talking to them about how to get weather information during bad weather. So it's a wide, crazy cross blend of society that we try to hit.
Making sure all data coming into the office as far as surface observations and upper air data is good. We quality control it. I also maintain a cooperative program network, which is basically weather observers.
Typically what I'm doing on a daily basis is studying the river channels and determining what areas will flood at what stages and building new impact statements for those stages.
An average day for our job is we go out, we talk with a lot of community groups, a lot of the plants, the refineries. We do a lot of preparedness talks. What's the upcoming hurricane season look like, things like that.
And a lot of times I do a lot of coordination with the River Forecast Centers, so I'm really the liaison between our office and the forecast centers at the River Forecast Centers.
How do you determine whether a storm is just a tropical storm or a hurricane?
When should we stay in place versus evacuating?
So with the new technology, do you encourage families to have the weather radio?
So what is the plan if we get massive rains like in Louisiana?
Channel 6 studios, and this is where we do the weather for television. We're in front of a wall, we call this chroma key. So we're seeing radar. You notice on these monitors on the left side and on the right side back in the corner, this is showing me keyed out. Everything in back is keyed out with the radar. It's kind of weird, but I am watching myself on TV. So anywhere I point, that's what's going to happen. So by looking at the TV monitors, watching myself on live television, I know exactly where to point and how to interact with those maps.
Do you have to memorize your lines or do they show you?
That's a good question. You notice above the camera, there's what is called a teleprompter. Now, I'll tell you a little secret about the weather. We don't use a teleprompter. So when I go out here and do the weather, I may have 3.5 to 4 minutes to do it. I'm strictly talking off the cuff. What I do when I do the weather, I usually kind of get a broad outline in my mind what I'm going to talk about today. What's the weather story today? People ask me, say, what are you going to say? I really don't know. I just look at the monitors and say, oh, that's interesting, let's talk about that. Oh, that's interesting over there, let's talk about that. And pretty soon, 3.5, 4 minutes is gone.
How do you alert the people when severe weather hits our area?
Okay, one of the best ways we do it is through television. Of course, with social media now, this is a whole new thing for me. We actually have a lot of people watch our updates on Facebook. And we do a lot of actual weather forecasts on Facebook, live videos sometimes. So that's a good way for us to get the information out. You know, 5, 6 years ago, that really wasn't an option. But since Hurricane Ike, which was the last big hurricane in 2008, these platforms are now available where we can get the information out.
How do you coordinate with the National Weather Service when our area is on tornado watch?
What we do is, of course, we know the warning or the watch has been issued from the Weather Service. Most of the time, we don't actually talk to them over the phone, except if I have information to pass along to them that they need to know. Let's say a viewer calls in and says, I'm on Interstate 10 and I see a tornado near Winning, it's heading up Interstate 10. I'll pick up the phone and say, hey, we've got a tornado reported by the public over here. I'll call Lake Charles, the Weather Service, and they'll put out a warning based on the report that we relayed to them. So a lot of times we're just passing on information to them, and they do the same for us. They'll say, hey, we're getting ready to issue a warning. They call us, they give us a little heads up. We know what's going on. So it's a cooperative effort.
What do you do when there's like a tropical storm or a hurricane?
Well, in a tropical storm or hurricane, it really depends, of course, where it's going to hit, first of all. We've had storms hit down in South Texas between Corpus Christi and Brownsville. Almost nobody lives down there. It's not such a big deal. But of course, we have a hurricane like Ike and Rita, which affected our area, heavy population, a lot of industry and everything. It can cause tremendous damage. One of the nice things, we mentioned tornadoes just a while ago. Tornadoes are very short-lived. They don't last very long. They strike suddenly and they're gone. A hurricane is an event that takes sometimes days to come to you. It may take a day to go through your area, and a couple days down the road it may dissipate. So you have a long time to prepare. So that one of the advantages of a hurricane, we can warn people very easily the storm is coming. Now, just because you may have good warnings doesn't mean you're going to keep people from getting hurt. It's still up to the people that hear the warnings to do the proper thing, and that's to leave.
I'm with the Jefferson County Office of Emergency Management. What our mission is to minimize loss of life and personal injury, damage to property and the environment from disasters. And we strive to accomplish this through a continuing program of outreach, coordination, planning, training, and exercise for all hazards and for all 4 phases of emergency management. Those are mitigation, preparedness, response, and recovery. Some of the things our office has been involved in going back since I started was with Hurricane Katrina, the evacuation of people out of Louisiana, Hurricane Ike, Hurricane Umberto, Hurricane Gustav. We had a Thanksgiving Day accident a couple years ago. We deal with pipeline leaks, any type of hazmat incidents, anything that involves more than one jurisdiction. They tend to call us to come out and assist with it.
When should we stay in place versus evacuating?
The county judge, based on information that we give him and from the National Weather Service, will either call a shelter in place or an evacuation. So, you listen to your TV or your radio and that message will come out. We also have an alerting system. We can go on a computer with the map and it'll call everybody within that circle. We have electronic billboards along I-10 and along Highway 69 to the south that put out different emergency management type messages. We have a website, setinfo.org, where we put out press releases and information that we want the public to have. And we go out and we talk with a lot of community groups quite often.
What supplies would you need if you were taking shelter?
We recommend 3 days of food and water, any medications you might have or might need, your prescriptions for those medications. If we're saying it's a mandatory evacuation, we're usually calling that for a reason. We try and get it up as quick as we possibly can, the power, the water. Sometimes the water's not drinkable because salt water got into it or something like that. So best recommendation I can give is don't come back until we say it's safe to come back, because it literally isn't safe to come back.
So what is the plan if we get massive rains like in Louisiana?
What happens in the summer, July and August, is it's really hot outside, right? So we get extreme temperatures. In the morning, it's cooler. As the day heats up, it creates friction in the upper atmosphere that causes these afternoon rainstorms we get a lot. Again, we'll get with the Weather Service and they'll tell us what we can expect, and based on the timeline, that'll start certain things. If it looks like it's something that our area can't handle rain-wise, we might start evacuations, or just certain parts of the county where they'll get underwater. We take our cues from the Weather Service.
Well, our vision is to have a weather-ready nation, that society is prepared for and responds to weather-dependent events or disasters. The main goal is to protect life and property. We are a government agency and we're underneath the Department of Commerce. If you have an ice storm, you're gonna lose your transportation infrastructure, you're gonna lose power, you're gonna lose business, airlines won't be able to go where they need to go. If we can plan ahead for it, we can kind of reduce the dollars we have to spend later.
Using satellites, how do you determine whether a storm is just a tropical storm or a hurricane?
A storm, like a tropical storm and hurricane, is just a cluster of a bunch of thunderstorms. And it makes it look like one big cloud structure. And so their analysts are looking at those clusters and analyzing what they call the Dvorak intensity. Now we have satellites that can give you wind speed estimates. Is the circulation closed? So a tropical storm is it's very similar to a hurricane, except for it has lower wind speeds. You don't get a hurricane until you get to 74 miles an hour.
How hot does the ocean have to be for you to start watching hurricanes?
It's normally around 80 degrees is where you can start to get a storm develop. Now, obviously, the hotter the ocean is, the stronger the potential for the hurricane.
Does the population increase flooding?
If you move more population in, you got to build roads, you got to build houses, subdivisions, you got to have grocery stores, parking lots, so that rain cannot go into the ground anymore. It just runs directly off. So you do cause more flooding, especially in urbanized areas.
How quickly can you tell when and where a rain bomb will fall?
A lot of the rain bombs form when we're not expecting rain. It's very interesting. We had an event over toward Lafayette several years back. The forecast was issued that morning. I think it had maybe a 20% chance of rain. They ended up getting 19.5 inches out of it. If you get 20 inches in a few hours, water is gonna go to places you never thought it would go before. Your homeowner's insurance is not gonna pay for that damage because our land is so flat. When it rains, it just goes up. And if you build your home at grade, right on the ground, that water is going to come into the door. So it pays for itself right off the bat if you ever have a flood. And the percent chance of that flood occurring gets higher each year as it goes along.
We live here in the tropics in Beaumont, Texas. and it rains hard, and sometimes it rains a long time. What we do is hold water and we delay that flood from getting downstream. Where we're standing here at the Chris Quinn Soccer Complex is actually a detention basin, and it detains water before it runs downstream and floods homes in Beaumont. That is our main goal at Drainage District 6, is trying to stop people's homes from flooding. But really it's more than just homes. It's not good when, for example, rice fields flood at the wrong time, it kills the rice. Or if the cattle have to stand in water for a long time, it ruins their hooves. So flooding is really not a good thing, and that's what we're trying to do at Drainage District 6, is prevent flooding. Well, this basin we're in right now is called Basin B, and it's this little one right here. This water, after it fills up, all these ditches drain water out of Beaumont, then we have a valve we open, and we let the water come on out of Beaumont. And it finds its way down all the bayous in Hildebrandt Bayou, and then Hildebrandt Bayou joins Taylor's Bayou, and it finally runs into the Gulf Intercoastal Waterway, which runs into the Gulf of Mexico, where all of our runoff eventually ends up. When this thing is full, all the water's got to run out somewhere at the bottom end, and we have a spillway at the bottom end that holds the water. Well, those are over there by the water tower. So we're going to go over there and look at those. This is where the water comes into the detention basin. It comes from across the street. We talked about 780 acres. When it rains, the big clouds come in and it rains and the water runs down the ditch. It crosses through a pipe right under here where we're standing, and it comes through these pipes that are under the road also, and it finds its way down this ditch, and it just fills up that detention basin where we saw all those kids playing soccer earlier. Now, the next day, when the rain has stopped and the detention basin is full, the ditch downstream has gone down and we're ready to release the water. Well, over here you can see the big gates we have that we opened that release the water. One thing I wanted to mention was this is called a spillway. It's in the ditch right here, and that's what fills up the detention basin when we have those big rains. And that gate over there, it's closed right now waiting for the rain. But when this detention basin is full and the ditch is empty, we'll open those two gates and we can empty this pond in about a day. Get it ready for the next rainstorm. We had a tropical storm came through here. It was called Tropical Storm Allison. It wasn't a hurricane. Well, it rained 34 inches in 3 days, and it rained 16 inches in 1 day right here in Beaumont. This soccer field basin was absolutely full to the top. Everything worked real well. We did have some home flooding, but it was way more rain, obviously, than we had anticipated. So you can't just build for, say, a 20-inch rain, because it's not likely to happen. So what we decided to build for is that 13-inch rain. Do you have a question?
So how do you know where to put the retention basins and how deep to make them?
Good question, yeah. A lot of people call them retention, but they're detention. We just try to place them where we know we have available land and where they'll do the most good to protect the most people downstream. Urban development actually causes the water to run off much quicker, and you have a lot more water you have to deal with, and will cause more flooding. That's why Drainage District 6 is working so hard to put systems in place that can handle development, you know, in Beaumont. That's right, more concrete, more parking lot, more roofs. That water just runs off a lot faster than it does, say, off of a field or a forest.
Is it worth it to get flood insurance?
Yes, ma'am. Anybody that asks me that, I have it, and it's definitely worth it because it's generally not very expensive per year, and if you do flood, a lot of people get surprised when their house gets flooded because it's never been flooded before. Almost any house, especially in Beaumont, as flat as we are, only 20, 25 feet above sea level, and we're so far from the coast, about 30 miles, it's so flat that as much work as we put into preventing flooding, I mean, it's still gonna happen. That would be our #1 mission, is to hopefully prevent home flooding. And then after that, you know, street flooding and crop flooding and so forth, just flooding in general. But the main goal we shoot for is to try to prevent floodwaters from coming into houses. So as you can see, we have smaller ditches that flow all through the detention basin that help itself, you know, drain. They're about 1.5 feet, sometimes 2.5 feet deep.
that keep the soccer fields good and dry too, but keeps the bottom of the basin dry that runs through here. So you're kind of limited on how deep the ditch is. That's a secondary use, we call it, of a detention basin, using it for a soccer fields. I mean, this is really neat because we needed this for a detention basin to prevent flooding. Obviously, a soccer field was needed. And I mean, this is a tremendous complex, and it's really neat that the soccer people and the drainage district, we can all cooperate to make something like that.
Some other weather observations that we collect are automated weather stations, which are located at every airport across the country. You got to have weather to fly airplanes. And a lot of these are maintained by the Federal Aviation Administration, but we do a lot of the maintenance on them. So that's why we're going to be able to go see one of these stations across the runway here.
What I'd like to show you is the Automated Surface Observing System. This is what we call the DCP, or Data Collection Package. The first thing we're going to look at is a visibility sensor. It's using a light beam. The light beam gets blocked off a bit. It actually translates that into a visibility reading. The next thing I'd like to go to is our temperature and dew point system. Over here on the left, that is your temperature sensor. And here on the right, that is your dew point sensor. And when you put them together, that's what gives us our relative humidity. Then we'll move down here a little bit further. We're going to look at the all-weather precipitation accumulation gauge. We call it AWPAG for short. So any rain falling into there, it measures the weight and converts it into hundreds of inches. Now this thing will go up to roughly 50, 52 inches. And then this is our anemometer right here. Now you notice it's got the prongs up on the top? Yeah. Well, it's actually, when the wind passes across it, it actually converts that into wind speed and direction. And the little building next to it, that's where the communications equipment is. So what it's doing is taking all this data and sending it to my office. And from there it goes into the NADIN, the National Data Network. The next thing we're going to look at is the laser beam ceilometer. What it's doing is actually sending laser beams straight up into the air. Now if it hits a cloud, some of that energy gets reflected back down, and it can determine, based on the time that it takes for that light beam to hit and come back down, it gives us a height of the clouds. The data is archived. The National Centers for Environmental Information, they archive this data once a month. So every ASOS in the United States, they're pulling in that information. This is the standard weather balloon. It's about 6 foot in diameter. We're going to take it outside. It's going to go up, it's going to be flying for about an hour and a half. When it bursts, it's going to be as big as this building. As a matter of fact, in the summertime, if we got light winds, you can actually watch it burst. It's 20 miles high, but you can still see the balloon. We've got the train, which consists of basically string and a parachute, and down there we have our instrument package. So what Danielle is going to do, we're going to walk it straight out the door, and I'm going to let you walk it out, walk the string, and then we're going to go ahead and get you the radio sign and you'll release it. You ready? Okay, that's right. And then just go ahead and unhook it from there, and we'll just walk straight out.
My favorite part that I got to experience today was releasing the balloon into the air.
Launch the balloon.
Balloon. Balloon launch.
The balloon.
Balloon.
When I was holding onto the balloon, I was really excited. You know, I was pumped up and I was really ready for this moment.
I would say the best thing that I've done today is watch the weather balloon launch. It was extremely interesting and fun to do.
Okay, you just hold it with your left hand, and then you hold the radio sign. All right, whenever you're ready to release. Now that balloon right now is going up about 1,000 feet per minute.
Oh.
But now that we've got the jets pushing down towards the south, our winds are stronger, it's going to end up too far away. Instead of just 20 miles up, it may be 60 miles out that way, and you won't see it.
With these computers, would you know how high the balloon was when it popped?
Yeah, the data as it's coming in tells us how high the balloon's going. Once the balloon pops, though, the data actually is turned off, and so that's the end of the data coming into our computer system. So anyone that has access to our website can actually see the data probably about an hour and a half to 2 hours after the fact. Yeah, TV stations, anyone that's interested in the weather, whether it's a TV station, a newspaper, any of the media people that have an interest in the weather, they grab our data, they can look at it, they may look at our forecasts, and they may say, well, the weather service says tonight's going to be 71 degrees, but you know, I think it might be a little bit cooler because it might get more fog in tonight. So they take our data, but in terms of what you actually see on the TV stations, they may be going right along with us, or it may be slightly different because they're meteorologists too, and they may have a difference of opinion in terms of what's going to happen.
All right, we're in the working area, I guess, of the Weather Center where we put everything together to put on television. So everything's computer driven. When I first started, a long time ago, 1979, we didn't have computers. So we did the weather with magic markers and magnetic symbols, believe it or not. We had two maps, a Texas map and a United States map, and that was it. There was no other graphics at all. Starting back in the early 80s, we started doing more computer graphics, and now everything's computer driven. So when we put together a show, for example, we're showing a video source here. This is the radar out of Lake Charles, Louisiana. It's pretty much live. And see this line of showers. These are showers and thunderstorms out here in the Gulf. That's the front that just passed us a couple hours ago. Probably if you've been outside, you notice the winds are out of the north. It's getting cooler. It feels better. It's not as humid. That's a cold front. And you can see it right here along the Texas coastline just offshore. You see this little symbol there? That's a pretty little good storm. That indicates a possibility of hail. So the computer graphics and the radar system can actually detect where the likelihood of hail would be. So you can see if I lived in that community, I might want to know about that. So we could get that information. That's one way we could show the weather on TV. We can also look at how it's been evolving during the day. You can start out at 8:15 this morning, see all the rain was along the coast. Here comes the front right there. And now it's moved out into the Gulf. So you can see how the weather changes throughout the day. Here's the satellite and radar both. And of course we can look at wider areas like this is North Texas. And you can see the front again moving down. It's all clearing out here. So even though it's cloudy here right now, what would be a good forecast for tomorrow? Anybody want to guess? Sunny. Yeah, very good. So if I was going to make a forecast, I'd say, I better look for what's going on up here because what's up there may be down over me tomorrow. And that's what's happening. See how everything is shifting southeast. The clouds are leaving and it'll be sunny tomorrow. So that's a good forecast. Very good. You're a junior meteorologist now. We can also look at temperatures, and you can see where the front's located. There's a lot of different ways to tell where a cold front's located. See, it's in the 70s and 80s here, 50s and 60s up to our north. So these are just some of the elements we can put together. We can, with the computer graphics, we can generate any type of map we want. We can look at any part of the world we want. But remember, when you're doing the weather, you have about 2.5 to 3 minutes of weather time.
Talking about the radar again, how high or how low does something have to be for the radar to pick it up?
Well, it's a straight line beam. So as the beam goes out, it's going higher and higher and higher in relation to the ground. So for example, this radar location is here. At this location, it's shooting through that cloud at about 6,000 feet. It's already up around 6,000 feet high. So to see something low to the ground, you have to have it pretty close to the radar site. So that's one of the problems with like severe weather, tornadoes. The tornado might be at the ground, but you can't see it because you're shooting through it at 6,000 feet. But the thing about tornadoes, though, is good is the fact that it's also spinning up there at 6,000 feet most of the time. So you can see it up above the surface and detect it on the ground by doing that.
For the technology, you said it progressed. How much has that helped? Has it made the delays less and all that? And what has been the best improvement over the technology?
Yeah, it allows us to tell the weather story more accurately, I think, than anything else. I mean, the technology is such now that we can use so much more information out there in a short period of time. We can forecast more accurately. There's no doubt about that. You know, when I first started, we did a 3-day forecast. And I didn't really like it because 3 days was too long to forecast. Then we went to a 5-day forecast. What is it now, anybody know? 7-day forecast, right? And there's some TV stations that actually do a 14-day weather forecast, but I think it's pretty stupid because we really can't tell beyond about 7 days very well.
So with the new technology, do you encourage families to have the weather radio?
Yeah, absolutely. The weather radio is very critical. It can tell, you in very quick matter of time what's going on. For example, if you're asleep, you're asleep. You're not paying attention to what's going on. You're having sweet dreams, right?
Hard sleepers.
Yeah, hard sleepers. But I tell you what, that weather radio goes off, it's going to wake you up. It's loud. It's kind of like a smoke detector. So it'll wake you up. You might say, oh, that's stupid weather radio. Well, it might be saving your life. It might be giving you information that you need to know. And like I said, the technology is now that there are not many false alarms. If that thing goes off, there's probably something right in your area you need to know about.
My favorite part about today was being in the studio with all the equipment. I just thought it was cool to see these things because I had never seen them before up close.
Getting able to look at all the equipment and talk to the experts.
Probably being able to see the actual processes that go behind the TV making process, besides just having a camera on a person's face.
I think my favorite thing was the green screen. It looked really cool.
Be working in the studio and working with the whole crew and meeting people.
Looking at all the recording equipment and how they recorded things.
My favorite thing that I learned today was definitely the balloon launch, because not a lot of people can say they have that experience, and now I can.
Science is really interesting, and I encourage people to study, and if they have a question, definitely ask it, because it'll open up doors to whole new questions, and you'll just keep on learning. It's a lot of fun.